So a very good afternoon to you all. So I welcome you all to this second session of the course Geoprocessing using Python. So as we explained in our introductory session, knowledge of any of the programming language is must for you attending this course. So anyway, experience with any of the programming language is fine, either Java, C, C++. So today we are starting with the introduction to Python so that programmers who have used other programming languages can be on the same page with the users who have been using Python. So this will be just a introductory session to the Python. So I will be covering during this lecture. I will be covering why we are using Python. Then we'll start how do we install Python and other things. Then basics Python syntax, some data structures in Python, and how do we write control flows and basic functions, plus reading writing files using Python. So to start with, why we are using Python. So according to the latest survey, Python is one of the most popular and fastest growing programming languages in the world. So it is growing quite rapidly, and it's even I think it has surpassed Java on the scale of popularity. Second reason is Python is quite powerful and it is fast as well. Actually, with the modern techniques, so it is the speed of the Python is quite comparable to the Java. So third reason is it runs everywhere. So you write code in any platform, so the same code runs everywhere. So you write Python program in for Windows system, the same code can run on Linux, Solaris, or Mac as well. So the most compelling reason what I find is friendly and easy to learn. So it's very easy to learn. So if you have either you have experience in some programming language or not, so you can pick up Python quite fast. So this is one of the most compelling reasons to go for Python. Python is open source, so you are free to use it. So it lets you work more quickly and integrate system easily. So as I explained, so Python is quite easy to learn. So you can learn it quickly and integrate multiple systems together very fast. Plus Python's documentation, tutorials, and guides are constantly evolving. Plus you have a large community support as well. So you get into any of the any problem. So there is a large community to help you out. Plus they have a lot of you will get a lot of tutorials and documentations as well, so you can learn it quite easily. So now let's see that how many there are different ways to run a Python program. First thing you need to install Python on your system. Actually, in the most of the Linux systems, Python comes by default. On Windows system, it may not be available. If then you can just download from this python.org link, or for Linux, you can download from these systems. Now, for running Python, actually, basically there are two ways. One is you can write your program interactively on the Python command prompt, or second way, just you can write your program in a script file, so that script file can be run on an interpreter. So you need not type the commands always. So whatever code you can write in a file and run it. So any file, you can use any file editor or some IDE for writing your code, or you can write even interactively as well. So now there are multiple implementations of Python available for uses. Depending on your requirement and choice, you can choose any of them. So first, the most standard is C Python. So this is the reference implementation. Like C, there are multiple distributions of C available, like ANSIC or Turbo C. So similar way, Python has multiple implementations. So C Python is the reference implementation. Whatever Python you download from the python.org, that is C Python. Plus, there is another distribution of Python, that is Anaconda. So Anaconda is a specialized Python distribution. This is mainly tailored for scientific programming tasks. So Anaconda distribution of Python is most popular among the data science community. Then another implementation is Iron Python. So this is an open source implementation of Python built on the .NET runtime. So if you want to use .NET runtime environment, then you can use Iron Python. Then you can use Jupyter Notebook as well. So it is a web-based interactive programming environment there. So I will be explaining more about Jupyter Notebook in the coming slides. So you can choose any of these implementation available. Actually, apart from these, there are other implementation as well, but these are the most popular ones. So we will be using for our demonstration the Anaconda distribution of Python. So what is Anaconda? So Anaconda actually is not just a Python distribution. Apart from Python distribution, Anaconda is a package manager as well. Package manager means, suppose there are multiple libraries available in Python. So installing those libraries manually is quite difficult. So package managers help you in installing. Like one library, the library will be dependent on many other libraries. So it may be using many other libraries. So you need to install all those libraries one by one. If you are going to install those libraries manually, it's very difficult. So package manager helps you in installing new libraries. So Anaconda is a package manager as well. The second thing, it is the environment manager. So environment manager means, suppose if you are running some multiple software. So some is running on Python 2, some are running on Python 3, and so on. So environment manager helps you in, suppose if you want to install 2 or 3 versions of Python in your system, so that like you have some legacy system that are running on Python 2.7. So those may not be compatible with the latest version of Python. So environment manager helps you in installing different versions of Python in your same machine. So Anaconda is a environment manager as well. Then Python distribution plus, by default, it comes with 1,000+ open source packages. So if you install Anaconda, you get almost 1,000+ popular open source packages already installed in your system. So how do you install Anaconda on Windows? So you can just go to the anaconda.com, and from there you can just install the Anaconda compatible with your machine. So once you download that, just I will be showing this. So for downloading Anaconda, you can just go on Google and search for Anaconda download. You can go to the page there, and at the last of this page, there are the Anaconda installers available. So depending on your platform you are using, maybe Windows, Mac OS or Linux, you can select the particular version of Anaconda compatible with your system. You can download it and install on your machine. So once you have, then you can follow the instruction for installation. Once you have installed Anaconda, then you have 2 options. So either you can use graphical user interface, or you can use command line interface for running Python. So suppose if you want to use For graphical user interface, there is Anaconda Navigator. And if you want to use command line prompt, then Conda Package Manager. So once Anaconda is installed on your system, then if you will see that if you search on your start button Anaconda, so you will be seeing these options, Anaconda Navigator and Anaconda Prompt. So if you click on Anaconda Navigator, you will get Anaconda Navigator. Actually, it takes a time to start. So I have already started on my system. So once you see it here, you will see a screen like this, Anaconda Navigator. So in Anaconda Navigator, first thing what you need to do, you need to create an environment. Suppose if you want to install Python 3.7 or 3.8, you need to just go to the environments and here create. So on the create, you can give your environment a new name, like whatever name you want to give. Like here I have given a name Spark Fun or any name what you identifiable name you can give to your environment. Then from here you can select which version of Python you want to install by default. So that particular version you can select and install. So this creates a new environment. Once the environment is created, it gets listed here. So once it gets listed, then you can activate any of the environment of your choice. So suppose if I want to activate the Spark Fun environment, I just can go here and click on Spark Fun. So here it says that, or I can just start from here, Spark Fun. So if I get Spark Fun environment gets activated. Now suppose if you want to install something on this. So for installing, you need to search, like suppose if you want to install a new library on this particular environment. So you can go here, not installed, and you can see that the list of packages which are not installed, or so if something is not available, you can search for the packages right here. And once this is done, you can just select and apply. So the particular package gets installed to your selected environment. So this way you can use Anaconda Navigator for managing your Python environment. And instead of this, suppose if you are the command freak, then you can go to the Anaconda command prompt as well. So in Anaconda command prompt also you can, like I have already created some environment. So there are multiple commands available for managing new environments. So just you can use like Conda create another command. Suppose I have already Spark Fun activated. Now I suppose if I want to activate this particular environment, so just I can do Conda activate and Spark Fun. If I do here, then it says the Spark Fun. So my Spark Fun environment got activated. Here I can run Python. So if I start here, my Python had started. So now here I can start writing code interactively. So suppose I want to write print a statement like print hello Python. So this way I can, suppose if I wish to write programs interactively, then just I can invoke the Python prompt, and Python prompt appears with triple greater than sign, and here I can start writing my code. So anyway, I will not be covering more about the command prompt based environment. I will be talking about using Anaconda Navigator only. So, but if you are using on Linux, you can go for this as well. Next is for writing the code, or whatever generally people use some IDE. So for this, we will be using Jupyter Notebook. So Jupyter Notebook is an open source web application for creating and sharing documents that contain live code, equation, visualization, and narrative text. So Jupyter Notebook runs on a browser-based environment. So you need to just start your browser. And in Jupyter Notebook, you can write your code as you write in your notebook. So you can insert new images, you can save the intermediate outputs, you can visualize graphs and everything. So it's quite rich and interactive environment. So Jupyter Notebook is popular among data science community as well. Plus, Jupyter Notebook supports multiple programming languages also. So like Python, or even I think Java also it supports. So Jupyter, so we'll be using Jupyter Notebook for our demonstration further. So here you can see that once you have activated your environment, so it will be listing like this. Suppose now you want to install Jupyter Notebook to your environment or any other package. So you can just click on the Jupyter Notebook here and install. Like actually in my system, it is already installed. So it is just showing launch. So you can either launch or like the packages which are not installed, it is asking you to install. So you can just click on the install so that Jupyter Notebook gets installed to your system. So once Jupyter Notebook gets installed, then you can launch it either from here. So then it opens a web browser. So then it opens a web browser. Or if you, so you can start either, you can start the Anaconda, your Jupyter Notebook either from Anaconda Navigator or directly once it is installed in your start prompt also it will be listing like Jupyter Notebook. And in bracket it will be showing the name of your environment. Like I've installed it in the SparkFun environment, so it is listing Jupyter Notebook SparkFun. So either you can start it from here or you can start directly from the Anaconda Navigator. So once it is started, so then you can see that Jupyter Notebook shows this. So for creating a new notebook, you need to just go to new and Python 3 or whatever. Suppose if I want to create a new Python 3 notebook, then Python 3 I can do, and it creates a name with some name. Though that name you can modify from here, whatever name you want to give to your notebook, you can do it from here. So, or suppose if you have already some notebooks created notebooks, then you can those notebooks you can open it from here. It will be listing all the notebooks, and you can open it from here. Now, suppose if you got a note, you downloaded a notebook from some internet or some other source. So that notebook first you need to, for running that notebook, you need to import that notebook to your environment. So for that, you need to just upload. Suppose if you got downloaded on some notebook shared by your friend or somebody from internet, so then for that you need to upload your notebook to your Jupyter Notebook environment first, then it will be listed here and then you can start it. So you can just go to upload, browse your notebook, and done. Once it is done, it will be listing here. So for today, now suppose if I am going to start this, Jupyter Notebook. Now, every Jupyter Notebook, actually now you see that there are two types of cells. In one cell, I have written just some description or text I have written. So this is a rich text. You can, using Markdown, you can write using Markdown text. You can write rich text, or you can write live Python code. So there are two types of cells. One is code cell and one is text cells. So there are multiple menus available here. You can see all those options. So suppose if you want to create a new cell, so you can create a cell plus by plus, you can insert a new cell, and from here you can just change the type of cell, whether you are whatever you are going to write in a cell, whether it is a code or some markdown heading or anything. So appropriately you can select from here. And suppose if I want to write a code, I want to write code in my cell, then I just will select it as code or type, or markdown. Markdown means here you can write HTML text in HTML form, or simple plain text also you can write. or you want it to be treated as heading, so it will be treated as heading. Like it is a heading. So there are two types. So two types of cell: markdown or and code cells. Plus from here, suppose if you want to interrupt your kernel, suppose your code is running and it is taking too much time. So you can, from the kernel, you can interrupt your execution Python interpreter. You can restart, clear outputs, restart and run all. Or once your kernel is running, you can just shut it down. If you have multiple kernels running, you can change the kernel. If you want to run your code on different kernels, then you can change accordingly. So there are multiple options. Basically, we will concentrate on the cells, either code cell or text cell. So this was the basic introduction to the Jupyter notebook. Now we will start writing code. I will start the basics of Python. So Python basics. So first thing, anyway, you must be knowing. So value. So what is value in a program? So value is the fundamental thing that a program manipulates. So value may be a string value or an integer value or floating point value or some Boolean value. So values are the fundamental thing that a program will be manipulating. By manipulating those values, the program will be returning you some results, or by manipulating values, you will be getting your desired results. So next thing, important thing is variable. So once you assign a name to a value, so that is called a variable. So variable is the most basic and powerful concept in a programming language. So a variable assigns name to a value. So variables are nothing but they are a reserved memory location that store values, and you give these locations a name so that those locations you can refer later in your program using those names. And one most important thing about Python variables is that Python variables does not need any explicit declaration to reserve memory. Suppose if you have used C or C++ or Java, so there you need to define the type of variable as well. Like suppose if you want to go to declare an integer variable, then you need to write int var1 or something like that. But in Python, we need not specify the type to declare a variable. So like here, the first thing, now suppose if you want to create a variable called message. In the message variable, you want to store a value hello Python. So, so in here, first thing you create a cell of code type, and there we are writing the variable name. So this is message is a variable name, and this contains the value hello Python. So for running a code cell, you need to you write your code and click on the run. If you run here, so this line of code creates a variable called message and stores the value hello Python in the message variable. Similarly, suppose if you want to create a variable that holds a numeric value. So here I am creating a variable named n and assigning it a value of 10. 10 is an integer. Similarly, suppose you want to use a floating point value. You can use e equal to 2.71. So once this is done, you can run these code cells one by one using run cell, run cell. Now suppose if you want to print the value of the variable message, so you need to just call the function print and pass it the name of variable which you want to print. So print message. So similarly, suppose if you want to print all the variables together, so same thing you can call print your message, that whichever variable you want to print, and comma, then suppose this is printing as a string, so n equal to then the variable n. So this is a static string, and this is the variable n, and e equal to e. So this prints this. So this way you can print the value of a variable. Now next thing comes a modules. Actually, what is a module? So module is like library in any other programming language. So module is a file containing Python definition and statements. So some reusable code can be written in, some programmers can write some reusable or most frequently used code in modules, so that modules or libraries can be utilized by, suppose some code is that is required frequently by many of the users worldwide. So what you can do, you can write those code in modular form and distribute it in the form of libraries or modules to other users, so they can just import those libraries or modules in their code and just reuse it. So module is just a file containing the Python definition and statements. So second, what happens, not all functionality available comes automatically when starting Python. So when you start Python interpreter, so all functionalities available or all libraries available in the Python standard interpreter doesn't come, because you will not be, suppose if Python interpreter loads all the modules available in the with your distribution. So what will happen? You may be using few of those modules. So if it loads all those modules, it will be just unnecessarily consuming the memory. So by default, all functionality is not imported in the Python interpreter. So some basic things only are loaded by default. So other things can be loaded later on. So extra functionality can be added by importing modules. So suppose you need some mathematical functions. So by default, Python interpreter will not load the math module. So you need to just import it and use it. So objects in that module can be accessed. So there are some other objects in that module, that objects can be accessed using the name of that module dot name of the object. Now suppose if I want to import the math library, by default the math library is not imported. So for that I need to just execute a statement called import and then the name of the module. So import math. So all, as the name of standard Python library is available, you can search the Google. So by default you will get Python built-in or Python standard library. So here you will see that this is a list of default modules available with Python itself. So you can load any of the module of you can search for your requirement. Okay, this module may be useful to you, or this will be this this is for fulfilling your requirement. So that particular a module you can select from here and import accordingly. So now here I am just importing the module named math. So I am just running it. Now in math module, there may be multiple functions available. Like suppose if I want math dot, so it has tab. It gives you auto completion as well. So in Jupyter notebook, if you write like math dot then p, if I type p tab, it lists me all the objects or functions available in the math starting with name POW. So if I POW and if I shift tab, if I press, it shows the documentation of the power function. So this is the whatever, if the developer of the library has written doc string or description of this particular function, that also you can access using shift tab. So with just tab, you can list all the functions available, and with shift tab you get the help of this on this particular function. Suppose if you don't know anything about this function and you want to know what action this function does, so you can just type shift tab and it returns you the documentation available with this particular function. So it says signature math.power. So it takes two arguments x and y, and it returns x to the power of y. This is a built-in function available in the Python. So if I call it like 2, 5, this function will return 2 raised to the power 5. So it returns 32. Similar way, there is another function called like random. Suppose if you want to import that function random, you can just import random, run it, and suppose if you want to generate an integer in the range 1 to 100, of the uniform distribution, you can just call random.rand in it. So suppose if you want to know what it is, what it does, random dot random.rand. So you can see that random.randin returns an integer in the range A to B, including both the endpoints. So it returns an integer in this range. Suppose any range you can specify. So all the time it will run a different function. So suppose if you want to generate a random number in this particular range, you can just run. You can see that every time when I run this code, it is generating a different number. So similar way, now there is another way, like suppose if you know the name of the module also inside. So you, instead of importing all entire random package, what you module, you want to just import some particular object or class from the whole module. So like suppose if you want to just import the path module from the pathlib library, only this particular class or object only, just if you want to import, there is another syntax you can use, from pathlib import path. So this way also you can import. So either you can write like just import path, then you need to call import pathlib, then you need to call pathlib.path. So instead of that, you can use from also. Now here you need not to use pathlib.path. Here you can just write path. So this way also you can import a module. And comments start with a hash. In Python, or I think in most of the programming languages, a comment starts with a leading hash. So any line starting with a hash is treated as a comment in the Python. So like here, if you see, though I have taken it as a code cell, but I have this line starting with a hash. So this line is treated as a comment. So it is not an executable code. This is a comment only. Now let us see, put it all these things together, variables, expressions, etc. together, and write a small program for calculating the interest based on some rate, principal amount, and time. So now here, let us see that we are getting a program from calculating some interest. So here we have created a variable called rate. So this is the rate of interest. So rate of interest, we have assigned it a value 10. The principal amount, you see, principal is equal to 1000. Then time, suppose 3 years or 3 months, whatever it is, you want to calculate the interest. Now here we have written an expression called interest equal to rate into principal into time divided by 100. So it returns me the interest. Now suppose if you want to, now interest variable holds the value of interest. So now if I want to print, you can just print that interest is this. Now these are there are multiple data types available in Python. So you can say first is numeric types. So numeric types, any numeric types can be further subdivided into integer types like 92, 12, 0, 1. So these are used for storing whole numbers. Then floating point numbers, like all floating point numbers 3.14 or any decimal point number. Then you can store complex numbers of form a plus ib or a plus ij, or whatever you say, a plus bi, that is composing of a real and imaginary component, where both a and b will be floating point numbers. Plus there is another type called booleans. Booleans is stored for storing true or false type of values. Then another type is strings. So string nodes like hello Python India or whatever. Then third type is sequence types. So sequence type is when you are storing a list. So list of 1, 2, 3, 4 or tuple or ranges. So these are called sequence types. So either numeric, string or sequence types. These are the basic data types available in Python. So next is indentation. So in Python, so generally in other programming languages, blocks of code are identified using curly braces or some other type of brace. Like in Java or C, the blocks, like suppose if you write some while or if, so this particular block of code is identified using a curly braces. But in Python, Python in Python, blocks of code are defined using indentation level. So all the statements which are at the same indentation level are part of the same block of code. And plus it imposes certain restrictions on the user. Actually, it has an advantage. So suppose you are writing programming Java or C. So every different users can write the block of code differently. So some may use different style of writing the code. But in Python, because you have to follow certain indentation scheme only, so all the programmers are forced to write code in the similar way. So your block will have similar indentation level. So like suppose, for example, suppose here if you take where you have started a variable x equal to 9. And now suppose if you want to write a statement if x is x less than 10, and inside this block we want to write to if this condition evaluates to true, and we want to execute two other statements. So these statements are will be at same indentation level. So if you see x and if these are at the same indentation level, so these will be running one by one. But this, if you see this print statement, these statements are at a different indentation level. So these statements are part of this if block. And once this print statement, if you see this statement, print statement is coming back to the indentation level of this if. Here you can see that we have left 4 spaces. So this is the different indentation level. So first line with less indentation is, so this is losing the indentation of 4 spaces, and until and unless we are going to use the same indentation level, once you decrease the indentation level, this statement will be outside this block of code. So here you can see these two print statements are inside this if block, and this particular print statement is outside this if block. So block of the codes are identified using indentation level in Python. So if you see that if, so these two, the value of x is less than 10, so this evaluates to true. So then it has written x is less than 10 and hello. Suppose if I write it 12, then what will happen? This block of code will not get executed, and this block will get executed outside you. So this way, indentation levels are used for identifying the blocks of codes in Python. Next, let's discuss about the strings in Python. So strings are the text values like any hello Anaconda. So in Python, strings can be any string variable you can enclose in a single quote, double quote, or even in triple quotes. Like here I am writing a variable spam x in a single quote. Now suppose you have to write like doesn't, but you can this forward slash you can use as a escape sequence. So doesn't. Now suppose if you round like doesn't, then either doesn't you can use escape sequence, or doesn't you can write in double quotes and this n as a single quote. Similarly, suppose if you have to write string in multiple lines, suppose if your string is spread over multiple lines, multi-line string you can write using triple quotes. So here you can see that this line is spanning over multiple lines, so that you can write using triple quotes, or just you can, instead of triple, you can just use this as well. So either single, double, or triple quotes you can use for writing a string. And there is another function like if you write 3 star un plus ium. So what will happen if you write in Java or C++, it will give you an error. But what happens here? 3 star, so 3, it will repeat un or whatever string you are writing it 3 times. So it will print 3 un plus ium. Or instead of 3, if I write 1, then it will be un plus ium. So plus strings can be indexed, like string is like an array. So string can be indexed with the first character having index 0. So if I write a string word equal to Python, so string, this character has index 0, then y has index 1, t has index 2, 3, and so on. So if I write word equal to Python, and if I print word 0, so the character p has index 0, so if I write word 0, it prints p. And if I write word 5, then it prints the last. Plus in Python, indices also can indices may also have negative numbers. So a negative number starts counting from the right. So the last character in the string will have index -1, then second last -2, -3, and so on. So suppose if I write in this word -1, so it prints the last character n, and word -2 will return the o. So similarly, we can continue decrementing word -3 and so on. So if you are using positive indices, it starts from 0, first character to the last character. And suppose if you want to use negative indices, then the last character in your string will have the index -1, then second last -2, -3, and so on. It will be in decrementing order. Plus, suppose if you want to get a slice, suppose you want to get 0 and 2 characters. Suppose from this string array you want to extract only 2 characters, 0 and first. So you can use a colon. So in your string name, in square brackets, starting and ending. So starting and 0 is excluded, including 0 and 2. So it returns you the characters at position 0 and 1. So it returns py. Similar way, 2 and 5, second, third, and fourth character. Plus, suppose if you want to put it in multiple, suppose instead of double or you don't want to use triple quotes, then suppose, and your string is very lengthy string, and you want to write it in multiple lines. So then you can use like this. Then you can plus an escape sequence and then keep on continuing in the next line. Now, if I print this way, you can write a string, multiple line string. Then second data structure is list. So list are ordered sequence of information accessible by index. So suppose you want to store the names of 100 students or 1000 students in your class. So then list will be a ideal choice. So ordered sequence of information accessible by index. So a list is denoted by square brackets. So generally what do you do? We do all the homogeneous elements are kept in a list. Suppose if you want to store, you can just this is the general convention. You can actually list can store elements of different type or different types of maybe string, integer, and all. But the general guideline is that you must use a list for storing homogeneous elements only. So list elements can be changed. So list is a mutable data structure. So suppose now I want to create a list. So for creating a list, I need to give it a name, like I am creating a list and assigning it to a variable called squares. So in square, with square brackets, you need to create a list of integers 1, 4, 9, 6, 25. So this way I am creating a list of square numbers. So if I print it, you can see that it has printed a list of squares. So each element of the list can be accessed using index, as we have seen in the string as well. Like if I print square 0, it returns the 0th element. Then similarly, square -1 will return the last element or 25 from the list. Similar way, you can slice a list. So here you are writing -3, then slicing with colon. So -3 actually to the right side of the column we have skipped. So it means starting from -3 to the last element. You can see that -3, this is -20, -1, -2, -3, so 9 to 25. So suppose if you want to add some more elements to your list, you can just use plus operator. So square plus and another list. So it creates a new list by appending a new list to the existing list. So square now 1496, few more elements got added to this particular list. Similarly, suppose if you want to, as I explained that lists are mutable objects, so you can modify any element of the list. So suppose this was the list. Now suppose if I want to modify third element to the new value 24, so now it is 65. Now you similar, I can modify it to 64. So now you can see the list contains 1, 8, 27 and 64. So similar way you have extracted. Now you can slices, you can assign also. Now here you can see that letters, I have created a list named letters and it is storing A, B, C, D, E, F, G. And now suppose if I want to change letter 2, 3 and 4 to capital C, capital D and capital E. So I can just create a new list letters 2 to 5. Letters 2 to 5 and I am assigning it new value C, D and E. Now if I print C, D, now you can see that A, B, C, C, D, E, F. Similarly, suppose now you want to empty the list. So you can just write letters and with slices start. If you are not passing any argument to the left or right, so it is assumed to be starting of the list and till the end of the list. And we are assigning with the empty bracket means this list will get emptied. So all elements from the list will get removed. Now if I print letters, it doesn't print anything. So next data structure we will be using frequently is the tuple. So tuple consists of a number of values separated by commas. Okay, so tuples is quite similar to the list. A list we were writing in a square bracket, but tuple we will write values separated by commas. Plus the second difference is the list is generally used for storing homogeneous elements, but tuples can be used for storing heterogeneous elements. So actually, whenever you are going to store heterogeneous elements, you must use tuple. And third difference is actually list is a mutable. So the contents of existing list can be modified, but tuple is a immutable. So you cannot, once a tuple is created, you cannot modify the contents of your tuple. So whenever, suppose if you know that, so how do you choose which one, whether to use list or tuple? So when your data is read only, so suppose you are going to read data from the file and you are not going to modify that information, so then you can prefer to use tuple. So tuple will be faster because it gives you only read only access. So whenever you are in your program, you want to access the data for read only purpose, so there you must prefer tuple. But when you have to modify the data as well, so then you can use, there you can choose to use a list. So let's see how do we create a tuple. So here we are creating a tuple, like I'm creating variable called t. So in that 1, 2, 3, 4, 5, 2 integers and 1 string I am storing to the tuple t. So t. Now if I print t, it prints like this. So similar the way we were indexing individual element of the list, similar way we can access the individual element of tuple as well. So suppose if I access t0, 1, 2, 3, 4, 5, it gives me 2, 3, 4, 5. So tuples can be nested also. Actually, here what was happening, these all were individual elements. Now the fourth element of tuple can be a tuple itself. So here what I am doing, I am creating a new tuple called u. So in that u equal to t, and here like in parentheses I am creating a values separated by comma. So now if u is a nested tuple, so first element of the tuple, if you can see 1, 2, 3, 4, 5, this is one tuple, and 1, 2, 3, 4, 5 is another. So now this u tuple is a nested tuple. So first element of this particular tuple is a tuple and second element also is a tuple. So instead of individual integer or string elements. Now element of the tuple is a tuple itself. So this is a nested tuple. But what happens, as explained, tuple is the immutable. Tuples are immutable. Now suppose if you want to modify the value t0 to some new value, so it will give you an error. So tuple object doesn't support item assignment because tuple is immutable. So once some value is assigned to an element of tuple, you cannot change it. Now, so you are suppose just writing a single statement, you can unpack the values of a tuple. Suppose our tuple T was having values 1, 2, 3, 4, 5, and 0. Now, suppose if you want to assign these to different variables, you can just write a single statement x, y, z equal to t. What will happen? It will break the tuple into and assign it to different variables. So now if I have x, y, z, x gets the first value, second, third. This way you can unpack a tuple to different variables. So next important data structure is set. So set is an unordered collection with no duplicate elements. So until now we have seen ordered collection. So in whatever order we were inserting elements to our list or tuple, so we were retrieving those elements in the same order. But set is an unordered collection. So once you stored something in the list and you just iterate over the list one by one, you may get the elements in different order than the order you inserted elements into it. Plus, set contains no duplicates. So set will contain only unique elements. So suppose you have to find duplicates or you have to remove duplicates from your list or something, then you can store it in a set. So set will not contain any duplicate elements. Duplicate elements will automatically be removed. So set objects also support multiple mathematical operations like union, intersection, difference, or symmetric difference as well. Like here you can see that we have created. So like set, how do we create set? So like lists we were creating with square bracket, tuple we are creating with just values separated with commas. Similar way, sets we can create using curly braces. So then curly braces, and inside curly braces, list of elements which we want to store in the set. Now here we can see that in the basket we are storing apple, orange, apple. So apple we are storing twice. So had it been a list, so it would have been printed apple twice. But now you can see that it is a set because starting with a curly brace. Now if I print this basket, it just prints banana, pear, apple, and oranges. So apple is printed once only. Orange also is printed once only, though in original it is appearing twice. So what set has done? Set has removed duplicate elements. Plus, moreover, you can see that the order is different. So suppose if I, instead of basket, if I say basket, underscore L, so basket underscore, had it been a list, so it could have, you have seen that it contains all the elements and in the same order. So it is the ordered collection. But in case of set, it has removed the duplicate elements and their order got changed. So this way, so sets you can use for duplicate removal. The next thing is, like, suppose if you want to check the membership testing, like some element is existing in your set or not. So for that you can use the in operator. Suppose if you want to check if orange is existing in the basket or not. So you can check like orange in basket. So your element which you want to test its membership, and in you can use orange in basket. So it will return you true or false. So it says orange in basket. So anyway, our basket set contains the orange variable, it is returns true. Now suppose if I want to check like crabgrass, whether it's in basket or not. See, crabgrass is not available in basket, so it must return false. So it returns false. Now similarly, suppose if you want to, you can use it for some mathematical operations also, like minus. So here we have created a set with variables A, B, R, this, and B. So what will be A minus B? A minus B will return elements in A which are not available in B. So suppose that if you want to calculate, so in your program, if a certain time, sometime the requirement may come like find the elements in A which are not available in B. So in other programming languages which doesn't support set, it will be quite challenging to write a program. So in set, in Python, it's quite easy. So you can just store your A's in one set and B and just perform A minus B. So A minus B will be give like all the elements in A which are not available in B. So B, D, and R. So you can see that B, D, and R are not available in B. So only it is giving only elements from A which are not available in B. So this way sets can be used for multiple purposes. So the next important data structure in Python is dictionary. So dictionary is a key value pair. So if you have used JSON or some other format, you must have come across this key value pairs. So dictionary is a set of key value pairs. So dictionaries are indexed by keys. So until now we were indexing the elements of set or list or tuple using integer indexes. But remembering integer indexes always is quite difficult. So there dictionaries come for our rescue. Suppose you have stored the address of each student, like name of the student and address of the student. Now suppose you want to retrieve the address corresponding to some student. So had you stored in a list, so you need to remember the index of each student, like student's name, like student's zeroth name is stored at this index. So then only you can retrieve the address of this. So if you store it in a dictionary, then you can access address of any student by using just its name. So you can use it for key value pairs. So dictionaries store a value in some key and extracts that value given by the key. See for an example. Now we are, suppose we want to store telephone numbers of multiple users. So here we are creating, so dictionary will be created like set only, but set was having only just these values like Jack or something. But here we have to we have two things in an element. One is key and another is value. Key, then colon, then value. So telephone number. So Jack has a telephone number 4098. Say 4139. So key values where key value pairs are separated using a colon. So defining a dictionary is like variable name and inside curly braces key value pairs. So this creates a dictionary. So in the list we were indexing elements by using integer indices, but here we can access the elements using string or key indices. So like suppose if I want to know the telephone number of Jack, so just I can write my variable telephone and the key for the Jack. So Jack is the key and 4098 is the value. Similarly, this shape is the key, 4139 is value, alpha is key and value. So now I want to get the telephone number of Jack. So I can, instead of remembering his index at which index Jack's data was stored, instead of that, just I can use the name of Jack for accessing the telephone number of Jack. So this way. Now suppose if I want to add new, suppose a new person joins in and his telephone number we need to insert to our dictionary. So that can be inserted using like telephone key equal to value. Telephone king is equal to 417. Now if I print my telephone dictionary, it prints king as well. Now suppose if you want to delete some value from your dictionary, then you can like delete then your dictionary and key. This key value pair you want to remove from your dictionary, you can just delete it. Now if I print telephone, so you can see that shape is removed from the. So similar way, membership can be checked using in operator. So king in telephone. So whether king key exists in telephone, if you want to check king in telephone, it returns true. Now suppose if I write green exists in telephone, it says false. So with in operator, you can check the test for dictionary membership. So similar, it was similar to list or tuple. So next is how do we write control flow statements in Python. So control flow is the concept of changing the order of code execution. So similar to the way you might use suppose sale price to decide which of car to buy. Like you may be seeing that okay, if this sale of this particular color is very high, then I will also go for this color only. So control flow is like if and else. Like if you are going on the passing through a traffic signal, so there like based on the color of the light, you need to change your course of action. If it is red, you need to stop. If it is green, you need to go. Yellow, you need to stop. So similar way, suppose if you want to write, you want to change the flow of execution of your code. So that control flow will help you in you. Like suppose here, I have a variable called traffic light. Traffic light, I am storing in a value green. So now I want to write if traffic light is green, then I will just want to print light is green and go ahead. And if the light is not green, then I just want to print stop. So how do we write? I have written a variable, I have created a variable called traffic light equal to green. And next I will write if and the condition. If traffic light, then equal operator equal green. Then I want that these statements to be inside this, then if should end with a colon, and next will be at the more indentation level. So this statement is inside this if this print is not matching the indentation level of this if this print is at a higher indentation level compared to this if, so it means that these two print statements are inside this if block. And once this else is coming at the indentation level of this f, so this else statement is not part of this if block. So these two statements only are the part of this if block. So if traffic light equal to green, then my first statement, second statement, then else print light is not green. So what happens? So first it will see that the color of, it will compare the value. If traffic light is green, so now the value is green. So it prints this statement, light is green and go ahead, and skips this portion. So we are changing the flow of execution of our code depending on the execution. Now here I can store something else, red. Traffic light, I am storing the value red. So it is showing that now this, first it went to this statement, red light is equal to green. So this statement evaluated to false. So then it skipped these two statements. Then it just came to this else statement. It says light is not green and stop. So similar way, suppose if you have multiple branching, so that also can be done using like if traffic light equal to green print, then instead of direct else, you want to write some more ifs. So like equivalent to switch statement. So if then elif. So if instead of writing directly else if, you need to write elif. If elif, and in the last you need to write else. So here you can see that only one of this code will get executed. Traffic light is equal to red. Now it will check if traffic light is equal to green. If this statement evaluates to true, so this statement will get executed. If this statement doesn't, and it will, if this evaluates to true, just this statement will be executed and it will come out of this if else block completely. If this evaluates to false, then it will check for the next. If this is also false, it will check for the next. If nothing of this is matching, then it will come to this last unknown traffic light. Like suppose if I run it here, it red, so then it light is equal to red. It came to this statement and came out of this. Now if I write here some RE, it will not match none of this and it will just print this unknown traffic light. So it will directly skip all these statements and come to this unknown traffic light. Now let us see that how do we write while loop in Python. While a while statement executes a block of code as long as some condition is true. So suppose you don't know how many times to run your code. So in that case you will prefer while loop. So while some condition evaluates to true, the loop will continue to run. So as soon as the condition becomes false, the code will come out of that loop. So in the cases where you don't know how many times the code will run, so in that case you have to choose while loop. So how do we write while loop? Suppose here I have defined a variable n equal to 0, and here I am writing while n is less than 10. While n is less than 10, print the value of n is n and n plus 1. So this first time when the code starts executing while n is less than 10. So n's value is 0. This condition evaluates to true. So it will print the value of n is n. Then it will increment the value of n by 1. So it will keep on going till it goes 9. So when n's value goes to 9, so it will increment, it will become 10. So n is less than 10, this statement will evaluate to false and it will come out of the loop. So this way you can see that this way you write while loop. While, then condition, then inside this we write our code. Then for statement. Actually, the for statement in Python is a bit difficult. It is not not difficult. It's a bit different from the for loops in other programming languages. The for loop in Python iterates over any item or list of sequences. Any item. So Python's for statement iterates over the items of any sequence. So generally in other programming languages we write for I equal to 0 to 10 this do. But in Python the for loop iterates over the elements of any sequence. The sequence may be list, tuple, or ranges. So like suppose here I have written a list called words. In words I am storing cat, window, and some other variable. Now suppose if I want to iterate over all elements of this list one by one, so for that I need to use a for loop. So how do I write? For w in words. So if I write for w in words, so this will iterate over every element of this words list one by one. So for w in words, so first time it will copy cat to the w variable, then second time windows, then defense trade. So this way for loop can be used. Now you can see that for w in words I am printing w and length of w. So for first time it is accessing the element cat, length of cat is 3, window, then defense trade. So this way you can iterate elements of a list one by one using for loop. Similar to other things, suppose now you are to other programming languages, you want to generate a sequence of numbers using for loop. So that also can be done using this for. So for that you need to use a function called range. So here you are writing for I in range 5. So range is a function. Range is a function it is taking. Suppose if you pass a single argument to this range function, range 5. So it will start from 0 and go up to 5, less than 5. So for I in range 5 will return a numbers in range 0, 1, 2, 3, and 4. So it will return a list of numbers 0, 1, 2, 3, 4, and we are then iterating over it using for loop. So 0, 1, 2, 3, 4. Similarly, suppose if you pass 2 arguments to the range function, it will be treated as start and end. If a single argument is passed, the starting will be assumed to be 0, and this will be your ending range. And suppose if you pass 2 arguments, and it will linearly increment by 1. Suppose if you pass 2 arguments to the range function 5 and 10, so first will be the start, second will be the end. So it will print from 5 to 10, 5, 6, 7, 8, and 9. Now suppose if you pass it 3 arguments, so 3 arguments will be taken as first will be starting, ending, and the increment in steps. So it will start from 5, 7, 9. So 2 is the number of increments in every step. So next are break and continue. So break statements break out of the innermost enclosing for or while loop. So suppose if you want to break out of your loop depending on some condition, so then you need to use break statement. Continue is for bypassing certain statement or skipping the remaining statements of your loop. Suppose if certain condition met, if that condition is met and you want to just bypass the remaining steps of your loop, so there you can use the continue statement. Like here, if I see, I have written a code here like for I in range 5, if I equal to 4, break, otherwise print I. What it does, for initially, if you see I equal to 0, 0, so this condition will evaluate to false, false, and then it will print I. So whenever I is equal to 4, it will break out of this loop. Even if I write it here 50, it will just print up to 4 only, because what is happening on whenever I is becoming 4, it will breaking out of this loop. Now let us see an example of continue statement. So continue is like, suppose if you want to see whenever I is equal to 2, you don't want to print I equal to i's value, or except 2's, you want to print other values of I. So then you can write like for I in range 5, if I is equal to 2, continue. Else means there is no else, print I. So whenever this condition evaluates to true, the remaining steps in this block of code will be skipped. So when I is equal to 2, this print statement will be skipped. So you can see that 0, 1, 3, and 4 are printed. But in case of 2, it skipped this print statement. So continue statement is used for bypassing part of code. And break is for breaking out from the innermost loop. Now let us see how do we write functions. So functions we write for suppose you have some line of code that is going to be used multiple times. Suppose you have 1,000 customers and you want to calculate the interest for all 1,000 customers for 3 years. So instead of writing code for calculating interest for all 1,000 customer differently, what you can do, you can write just a function for calculating the interest, pass it like for the duration, principal amount, and this and all. You can pass it and calculate the interest for reusing the code. So for same bit, for using the code, you can write functions. So how do we write functions in Python? So functions in Python start with a keyword called def. So def means definition. So def, then name of your function. Then inside parentheses, you need to pass it the arguments of the function. So def, name of the function, and inside parentheses, the arguments which you are, or parameters which you are passing to the function. So here I am writing a function for checking whether the passed variable is odd or even. So def, name of function, then argument, then inside this I am writing the logic as a colon, and after the colon I am writing the logic for the function. If I modulus 2 is equal to 0, I is an even number, else I is an odd number. So once a function, I have defined a function. Now just defining the function doesn't do anything. So for getting some useful results from the function, we need to call the function. So how do we call the function? So a function can be called using name of the function. While defining the function, you use to diff, and while calling the function, name of the function, and pass it the arguments required by the function. This function is taking a single argument named I for calling the function name, and inside parentheses the argument. So we are passing it the argument 10. Check odd even 10. So it is showing that 10 is an odd number. Similar way, you can call it for an odd number also. It shows that it is an odd number. Next thing is a default value argument. So sometimes what may happen that you want to define a function with multiple arguments, but you want to, like if you are not passing some values to the parameters to the function, then you want to take it default values. Like suppose you are writing a program to calculate the interest. Generally what happens, rate of interest is same for all the accounts in general. So then you can define a function like def calculate interest, here principal. So principal value has to be passed by the callee, but rate and duration, if the callee is not passing these rate and duration values, so by default the 5 and 10 values will be passed to the call function. So here you can see that we have defined calculate interest is equal to principal into rate and duration by 1000, and we are calculating something. Now suppose if I call the function calculate interest with just one argument 10. So by default we are not passing the argument rate and duration. So by default it will take values 5. So if I I'm printing here rate equal to 5, duration equal to 5 by default, though we have not passed in values, rate and duration. Now suppose if you want to override any of the default value parameter. So now rate, instead of 5, I want to change it to 10. So then while calling, I can just call calculate interest and rate is equal to with new value. Now here you can see that rate has changed to 10, duration still remains 5 only. Similarly, you can override other argument also. Duration also, if you want, you can change. Next thing we will see that how do we read and write files in Python. So for reading the file, you need to call the function open. So suppose first I am calling the function open, passing it the name of the file which I want to read. Suppose if you just pass on the name of the file, it will be checked in the current working directory. And the second argument is whether you want to open the file for reading or writing. By default, it will be reading. Anyway, even if I don't pass it R, it will be reading only. Suppose if you want to open the file for writing, then you need to pass the write. So F equal to open, name of the file, and the mode in which you want to open the file. So R means reading the file. Then once file is opened, it returns you a file object. You can call in this file object read. So read will read the entire contents of your file. Then it will return it to the lines. Then you can just print it on the lines. So there is no file called workfile.txt. So I will just create a file with name workfile.txt. So I have stored it in D drive. So you can see that I created a file work.txt, and in that I wrote 2 lines, hello Python 1 and Python 2. And just I read, so open the file, and on the file object I need to call the function f.read. So it returns me all the lines. So once the file is read, for freeing the memory and other resources associated with the file, you need to just call the f.close. If you don't call f.close, unnecessary file will be opened in the memory. It will be consuming your resources. So it is the best practice. Once the file is read or your work is complete, you must close it. Now, next is suppose if you, instead of reading suppose if your file is very big and you have limited memory available. So what you want to do, you want to read the file line by line. So that also can be done. So that can be done using, instead of directly calling f.read, what you can do, once file is opened, f equal to open work file.txt, then you can iterate over the lines. Like for line in f, you can write it like for line in f, print line. And finally close. So this will read this will read the contents of file line by line. And suppose if I don't use end, you will see that it is printing double slashes. So here I am just writing this. Now suppose there is another construct you can use with context manager. With construct, if you write like this is the other way to write, you can open the file in with construct. So you can write with open and your file as R as F and for line F. So here what happens, once you get out of this block with context, the file gets automatically closed. Even if you need, then the file gets implicitly closed. You need not call the close function explicitly. So this is the best practice for opening the file. You need to open it with the with construct. So with open file as f or line in f, and so automatically f dot close gets called. You need not call this. So this way you can. So this is the best practice for. So here, even if you forget to call, means you need not call. Even if you forget to call the close, automatically Python closes the file after reading is complete, or once you get out of this with block. Similar way, suppose if you want to write something to the file. Now I will write it here only. So right now, if you see here in D drive, there is no file with work file to name. Now for creating a file, what you need to call, like here, I'm creating a value equal to the answer is 42 or tuple. Now I am opening same way the file with open D drive work file2.txt, and I am opening this file for writing. So previously I was opening it for reading. Now I am opening it for writing. So same thing. Instead of reading, writing as f, and I am converting this value to a string with a str function, str. Then finally, instead of read, I need to call the function write. So f dot write as will write. Anyway, I have opened the file in with context manager. So automatically, I need not close it explicitly. The Python automatically closes it. Now, if I see here, there will be a file with the work file 2.txt. Here I have written the content. The answer is 42. So this way we can read and write files. So this was the basic introduction to the Python. So I installed Anaconda in my local system and Jupyter notebook also. So I will be continuing on my local system only. So suppose if you are not interested in installing the Jupyter notebook or Anaconda in your own system, there is an alternate also available. You can use Google Colab. So Google Colab is a cloud-based platform. So there, this is Google Colab is a Jupyter notebook environment hosted on the Google's cloud. So you can directly use Google Colab as well. So you will get all the mostly whatever libraries you will need for this course will be already pre-installed on your Google Colab account. So you need not install anything on your local system. So for accessing this on Google Colab, you can just search on Google Colab. So if you don't want to install on your system, you can go to Google Colab. Google Colab is free. So you need to just log in with using your Google account. And here you can just write a new notebook. And it also has a similar interface, slightly different from our local Jupyter notebook. So here also you can start writing your code. And you can just run by clicking here. So you need to wait for it to connect. Then you can start using it. So when this turns to green, it means it is connected to the Python runtime. So if I write A, you can just run it here. So you can use Google Colab as well for practicing these things. So this was the basic introduction to basics syntax of Python. So tomorrow onwards we will start some basic libraries. So tomorrow I will be introducing you to the NumPy and Matplotlib, which will be using further in our geoprocessing. So I think you can just revise the basic syntax of Python before tomorrow's class, so it will be helpful for you. So that's all for today. Thank you very much.